Okay, we're in section 19 of the notes, logs. And the deal here is that if you don't have the background in 119, it's going to be a tough section, right? You need to understand there's a prerequisite for the course. The prerequisites are pre-calculus. So you need to understand 119 to be able to do calculus. All right. I'm going to the whiteboard, but as I go to the whiteboard, we'll discuss this from a 119 perspective, but we do need to move into a 121 perspective. All right. So we'll talk about derivatives of log functions. That's 121. We'll talk about what happens to other bases related to math 121 and 119. All right. And we'll go on and on and on, and then we'll get to the examples. All right. But first, a lecture. Let me switch screens and let's start. Okay. So much of what we do in Math 121 depends on the material covered in Math 119 and 120. This section is going to depend on 119 though, and that's because it's based on your knowledge of logs, all right? So the thing I want to get across to you is that, when you did 119, you talk about log functions, and log functions were related to exponentials. So my claim over here, looking at it, just from the 119 perspective, that the log base A of X, if I were thinking about that back to 119, when we told students at 119 that the logs are kind of foreign to us. So we rewrote it. And what we wrote it? We wrote it as an exponential. And what we said, this really is X equals A to the Y, which had easier meaning for us, all right? When someone says, why is that? Well, it's easier for us to deal with it, all right? So the bottom easier means that at the 119 level, we could start graphing these things out, all right? So I want to go back and I want to talk about, before I do that, I should mention that the A in 119 was going to be any number, any positive number. I'll put this over here. However, we didn't like 1. The reason for that, 1 to the Y is always going to be 1. So I'm going to say A not 1. Y can be any real number. And the X has to be greater than 0. And just look at this to know why. All right. We're raising A. That's a positive number to Y. So the X got to be a positive number. All right. So I'm going to look at the graph now. And someone says, why do you look at a graph? Just so we can understand what the graph has given us. And so this is a graph. I'm going to write this down. It's labeled for us too, but I'll label it over here. This is the line Y equals X. So I bet this has something to do with inverses. And let's talk about it. The first graph I recognize, that blue curve. So the blue curve I recognize as being an exponential, Y equals. Well, they're telling me the exponential here is Euler's numbers to the X. Now, of course, what's this one over here? It's the inverse. So I have to write that one there as the inverse. And I hope you realize the inverse of that would be Y equals log base E, which at the 119 level we call natural log. All right. All right, let's look at e to the X. Think about the domain and range of this thing over here. The domain of this are real numbers. The range of this, well, let's see, it's going to be from 0 off to infinity. Let's talk about this now, which is the inverse function. The domain of this is 0 to infinity, and the range of this is minus infinity to infinity. You should see these things as being inverses. Just like it's covered in Math 119. All right, so that's kind of done. I'm going to look at this next thing up. I just a little bit of review of what you did in Math 119. And it says, things that we probably should know by now. And one of the things that we should probably know by now is we should know the derivative of e to the X is e to the X. That's nice to know, by the way. So we're going to use that to find the derivative of this. And let's see if we can do that. I'm going to put the work down for you. We'll turn the page in a second, by the way. So if Y equals the natural log of X, I'm going to write this a little bit differently. I'm going to write it as X equals e to the y. Right, what I do, I took something that's unfamiliar to me and I wrote it in terms of familiar functions for me. So I'm going to take the derivative of both sides with respect to x. Well, that's pretty easy because derivative of e to the y would be e to the y. Derivative of y is dy dx. Well, let's see. The derivative of x is just one, right? Let's write this down now. So dy dx equals 1 over e to the y. Well, this kind of reminds me back to the arc, arc sine, arc cosine. And there's nothing wrong with the answer, but you wouldn't look in a book and see that. And do I know what e to the y is? I do. And what is it? It's x. So what's this 1 over x? So write this down for you. We'll look at the next page later. But if y equals the natural log of x, dy dx is really simple. It's 1 over x. We're done with that. Next page. Next page goes through that derivation and writes that down for you. Now comes the problem is, what happens when you get other bases? E is nice though. So I'm going to say, if there's anything you can remember from today, you're going to remember this. Log base a, x, should be rewritten as a to the y equals x. That's one thing you should know for sure. You should know the domain of this. That's the x values. The x values over here, this is the domain of the problem, have to be greater than 0. The range of this, that's the y values, minus infinity to infinity. We just covered that. What else are you going to remember? Well, if y equals the natural log of x, its derivative, we just derived this, by the way, is 1 over x. All right, let's take a look at this now and see if we can figure it out. So what are they getting over here? They say, what happens if you get other bases? What are you going to do now? Let's write this down. Y equals a to the x, a greater than 0. What I'm going to do is I'm going to take natural log of both sides. Let me write that down for you. What do you get there? X, ln a. Then they're going to take the derivative of both sides. What's your natural log? It's 1 over y dy dx. What's your the right-hand side? It's just the natural log of a. Let's write this down now. So dy dx equals y times the natural log of a. Do you know what y is? It's right up here. So dy dx is a to the x times the natural log of a. So let me write that down for you. Important result. If y equals a to the x and a is greater than 0, I know its derivative, dy dx, is going to be equal to a to the x times ln a. Now someone says, do I need to remember that? I don't know. I wouldn't remember that though. I would derive it. All right, let's keep going. By the way, this stuff's written over here for you, including the work. Let's talk about logs now, different bases for logs. And to do that, what I'm going to claim over here is I'm going to use a base change formula, but I want to derive it for you. Now, some people say, no, I can remember everything I was given in 119, but it's not so much about remembering, it's about understanding where it came from. So if y equals if y equals the log base a of x, what I'd like to do is I'd like to rewrite it in familiar terms. What would I get? A to the y is equal to x. Well, gee, this is familiar. I'm going to take the natural log of both sides. So the natural log of a to the y is equal to natural log of x. The y comes down. These are rules of logs. You've seen this before. Natural log of x. What do you get? Y is the natural log of x divided by the natural log of a. This in 119 was called a base change formula. Now, why is this going to be nice? Well, we're in calculus. It's going to be nice because we can take derivatives now. What do we take derivatives? Certainly a natural log. Let's go to the next page. And let's see if we can do it. Let's write this down. So y equals log base 3 of x. But let's say someone said, what's dy dx? I say, I don't know. What I'm going to do though, I'm going to rewrite this using the base change formula we just derived. What would that be? Natural log of x over the natural log of 3. This is y equals the constant 1 over the natural log of 3 times the natural log of x. Dy dx is going to be the constant 1 over the natural log of 3, which of natural log of x? 1 over x. So I get a pretty simple statement over here, and I'll write down for you. Now, someone could say it's simple, but I'm going to memorize. We're not opposed to you memorizing. I'm just going to say it's not a good long-term strategy. This is 1 over x ln 3. Look at the key. You'll see it right over there. Okay. Here comes the problem. We need to understand what was presented today. So that means you should study what we gave you. What after we study that, we need to reinforce it by doing these examples over here. So, bottom line is you might have to go back at this a later time, look back over what we said, try to make sense out of it, try to relate it back to what you did in Math 119, but we do need to move forward. And that's in a sense, we need to go back to calculus. What is calculus all about? Differentiating. We'll go through the examples. Some of the examples will be differentiation. Some of the examples will just be a review of what you've done in Math 119. There's nothing wrong with review. You want to review. You probably should be reviewing on your own now. And the more study time you put in, the easier this stuff is going to become. Thank you.